Alright, let's tackle question 2 from the chapter. The Haverford Company is considering 3 types of plans to make a particular electronic device. So plan A is much more highly automated than plan B and so on. So important information is, for each type of plant, average variable cost is constant so long as output is less than capacity, which is the maximum output of the plant. So if you look at plant A, the annual capacity for production is 200,000 units of output. So as long as the output is less than or equal to 200,000 per unit, average variable cost, which is found here, 250 per unit. But if you exceed 200,000 output, then you have to build plant A that has same specification like this. So that is assumption hidden in this question. So the cost structure for each type of plant is as follows. So you're given with cost structure for plant B and plant C. What about the question that follows? So question A and question B, C ask you to do the same thing for each plant. So question A, for plant A, derive the average cost of producing 100,000, 200,000, and 300,000 and 400,000 devices per year. For the last 2 quantity of output exceed the capacity. So for those, assume that you can build the same type of plant A additionally that preserve the same cost specification as I mentioned earlier. You do the same thing for question B and C, for plant B and C respectively. In question D, once you have gone through ABC, then plot the points on the long run average cost curve for the production of these electronic devices for outputs of 100, 200, 300, and 400,000 devices per year. So question D is, given plant ABC cost structure, which one is most cost efficient in the long run when you have flexibility of changing plant or technology? Alright, question A, derive the average cost of producing 100,000, 200,000, 300,000, and 400,000 devices per year with plant A. So recall average cost by definition is total cost divided by quantity of output. And total cost is written as total fixed cost plus total variable cost, and you divide by Q, and the first fraction on the left is average fixed cost, and the other one on the right is average variable cost. So, for example, when the company produces 100,000 output, let's say Q equal 100,000 output, then at that level, average cost at the level, you have to calculate average fixed cost. So 100,000 is less than capacity of plant A, which is 200,000. So in the case, fixed cost for one plant stays as 300,000, and you have to divide by total output, 100,000. So you can calculate average fixed cost and average variable cost. As long as you produce less than 200,000, the capacity for the plant A, the average cost, average variable cost, stays at the same level, which is 250. So by canceling out these 50, we have 550 average cost for quantity 100,000. You can do the same thing for 200,000 output level, average cost. Again, this is below or equal to annual capacity for plant A. So fixed cost for one plant A stay at 300,000, and you want to average it for 200,000 unit. So divide by 200,000, but then this quantity 200,000 does not exceed the capacity of plant A, so variable cost stay as 250. So this will be 15 plus 25, so it gives you 400. So $4 average variable cost to produce 200,000 units. What about Q equal 300,000? This exceeds the plant A capacity 200,000. So that means you have to build another plant A, which also costs total fixed cost 300,000. So now to run plant A, two of them, you have total fixed cost 600,000. So here variable cost changes as total fixed costs become double. 600,000 divided by 300,000. But then variable cost, average variable cost, stay the same as 250 per unit. So by calculating it, you have 450. And for quantity 400, again, two plants A, two of them can cover 400,000. So your average cost again has components 600,000 total cost divided by 400,000 units, and average variable cost 250. So you have 500. This one is not 500. This one is 15. So you have $4 average cost when you produce 400,000 units. That's for question A. Question B. So we are looking at plant B. Okay, question B, plant B. Again, you want to write average cost, which is total fixed cost plus total variable cost divided by quantity Q. So you want to find out this first term and average variable cost, which is given in the table. So for plant B, average variable cost is always $6. So figuring out average fixed cost, that's the tricky part. So when quantity of output is 100,000, average cost 100,000 does not exceed the capacity of plant B, which is at 100,000. So total fixed cost will be 75,000, and you're producing 100,000. So that is average fixed cost, and add up 6. Then here is 3 over 4's 0.75 plus 6, which give you 675. So that's the average cost. When Q equal 200,000, then that exceed plant B annual capacity. So you need to 2 of plant B. So your fixed cost doubles of 75,000, which is 150,000. And you divide that total cost by 200,000 output and add up average variable cost. So you will have again $6.75. When Q equals 300,000, again another additional 100,000 units require one more building of plant B. So average cost increases as the total cost become triple of the 75,000, which is 225,000, and divide by 300,000 and plus 6, then you have 675. Then maybe some of you already predicted 4,000 unit. Again, average cost will be same as 6.75, as average variable cost stay the same, and you're increasing the unit by 100, and again you're adding one more plant B. That cost total fixed cost increased by again same 75,000. So here you have 300,000. So that is the answer for question B. For question C, now we are looking at plant C. So do the same thing, 100,000 unit that is below, that exceeds plant C require 2 of plant C. So your fixed cost, total cost, become double immediately. So 25,000 multiplied to 50,000 total fixed cost divided by 100,000, and average variable cost is $7.50. So you have $8 average cost when you produce 100,000. For quantity 200,000 average cost, now you can also expect that you again need additional 2 plants C, which double your cost from 50,000 to 100,000 divided by 200,000 plus 750. So you can imagine again your average cost is $8. So this continue for the other quantity, like the same logic you've seen in the question B. So for plan B and plan C, their average cost stay the same at $6.75 and $8 respectively for each possible quantity of production. So question D, using the results found in the previous question, plot the points on the long run average cost curve for the production for outputs of 100,000, 200,000, 300,000, and 400,000 devices per year. So in the long run, there's no fixed factor like plants. So plants can be changed from cost inefficient type to cost efficient type. So as you know, plant A, the average cost only ranges below 550 from the minimum 400. So it's the cheapest plant to produce each quantity of output compared to other plant B or C. So in the long run, when the manager can change the type of the plant or size of the plant and can build extra unit of the same plant, the manager will choose plant A for producing 100, 200, 300, and 400,000 units of devices for the year. So we are basically drawing the plant A's average cost curve for given output. So if you draw here, then quantity of output here is, and we have 100, 200, 300, 400, thousands. So here is 1,000, or you can say 1,000, and here is average cost for plant A, which becomes long run average cost curve for this company. So 100,000 units was produced at average cost $5.50, and for 200,000 it was 400 here, and 300,000 it is $4.50, and 400,000 it again fall back to 400,000. So long run cost curve looks this way. Thanks for watching.